Hello everyone, I welcome you all to this class. Recall that the polar form of a complex number z, which equals x plus iy, is given by z equals r into cosine theta plus I sine theta. Let us call this equation 1, where this r is the modulus of z. That is what we studied in our previous video. Now, and in our previous video, I told you that this theta is measured in what? Radian. And in this theta is the principal argument of the complex number. Now, with the help of the Euler's formula, this symbol exponential I theta can be expressed in terms of cosine and sine. So this simple exponential I theta by the means of the Euler's formula is given by exponential I theta to be equal to cosine theta plus I sine theta. This is the Euler's formula, where this theta is in what? In radian. So if we substitute this, let us call this equation 2. If we substitute this equation 2 in our equation 1, which is the polar form, we have gotten this part from here to here by the Euler's formula. From here to here is equal, that's from here to here is equal to what? Exponential I theta by this equation 2 by the Euler's formula. So that if we substitute this exponential I theta for cosine theta plus I sine theta in equation 1, you are going to get z equals r exponential I theta. So this expression z equals I exponential I theta is called the exponential form of a complex number z. So this is the exponential form of the complex number z. So with this, we can express any complex number in exponential form. Any complex number, we can express it in what? Exponential form. Let's just see how we can express this very complex number in what? Exponential form. Solution. Now, first of all, find our what? Theta. What's our theta? The principal argument. So let's just find the principal argument of this very complex number. Now, in our previous video, when we were studying principal argument, I gave you a formula you are to use. And the first formula I gave you says that if the real part of the complex number is positive, then your principal argument is given by tan inverse of y divided by x, where y is the imaginary part of the complex number and x is what? The real part of the complex number. So we are going to use this formula. Why? Because the real part of this complex number is 1, right? Positive 1. So the real part is positive. So we are going to use this formula to get what? The principal argument of this complex number. So this will be equal to what? Tan inverse of what is the imaginary part, which is our y, coefficient of I. What is the coefficient of I? Negative square root of 3. Negative square root of 3 divided by what is the real part? 1. So this will be equal to tan inverse of, let's write it here. This will be equal to tan inverse of negative square root of 3 divided by 1 is what? Negative square root of 3. So we are going to have tan inverse of, okay, this we can bring out negative, this negative out of the tan, right? Out of the tan inverse. So this will be equal to what? If I bring out this negative, I have negative tan tan inverse of square root of 3. So this is what we are going to get here. So I just brought out this negative sign out of the tan, or out of this tan inverse. So this will be equal to negative. What is tan inverse of square root of 3? Okay, tan inverse of square root of 3 in our previous video I told you is what? 60 degrees. 60 degrees. But our angle must be in what? Radian. So you convert 60 degrees to radian. How do you convert it? Multiply it by pi over 180. Multiply by pi over 180 degrees. Now 0 can cancel 0. 6 divide itself 1. 6 divide 18, you get 3. So what do you get? Pi over 3, right? But we brought out this negative out, which is this negative. So what will be our answer here? Our answer will be negative pi over 3. So negative pi over 3 is what? Is the principal argument of this complex number. So what do we need again? We have gotten our theta. We need our what? The modulus of z for us to express this complex number in a exponential form. Modulus of z is equal to square root of, in our previous video I have already given you the formulas. So the modulus is square root of the real part square. So the real part is 1. So the real part square plus the imaginary part square. What's the imaginary part? Negative square root of 3. Negative square root of 3. Then you square it. So this is the formula. So this will be equal to what? Square root of 1 squared is what? 1. Then negative square root of 3, all squared will give you what? 3. So you have positive 3. Then 1 plus 3 is what? 4. Square root of 4 is what? 2. So with this, we have gotten the what? The modulus of this complex number. So we are now ready to express the number, our complex number in what? Exponential form. So exponential form of the complex number z is given by r exponential I theta, right? So this will be equal to what? What is our r? The modulus of z, which is 2. Then exponential. What is our theta? Negative pi over 3, right? That is negative I pi over 3. So with this, we have expressed this complex number in what? Exponential form. We have expressed it in exponential form.